In this video, we're going to do a quick example where we're given the information about the magnitude and the direction of a vector, and we're asked to find its components, both its x and y components. All right, so we're given a vector v with magnitude of 3 units and angle 30 degrees, which is measured counterclockwise from the positive y-axis. What are the components of V? So what I'd like you to do is to pause the video here and try to do it on your own before we do it together. All right, so the first thing you should do whenever solving these problems, and really almost whenever solving any problems in physics, is start by drawing a picture, because we really need to think about what we mean by measured counterclockwise from the positive y-axis. So this is what your picture should look like. Here we have our x and y axes drawn in the standard way, and our angle is measured counterclockwise, which again is sort of going this way, the opposite direction of a clock, and it's measured from the positive y-axis. And right, this is the positive y-axis. So that tells us it's this angle that we're being given. If you got that incorrectly the first time when you tried this problem, I recommend you pause the video again here and try to do it again, knowing that this is the correct picture. All right, so once you have that, again, we always want to draw a triangle, a right triangle on top of this so we can use our trigonometry, where now the right angle is this angle, and then our angle theta, sorry, the picture was a little sloppy, is down here, that angle down there. All right, all we've got to use is SOHCAHTOA, and with a bit of algebra, what you find is the y component of this vector is its length times cosine of the given angle, and the x is the length times sine of the given angle. Now you'll notice something that we haven't actually seen yet, which is that I've added this minus sign out in front. And why is that? That's because I can see visually by looking at it that it is explicitly pointing in the negative x direction. Now, using sine, cosine, and tangent when describing a right triangle, because you're calculating lengths of a triangle, you're always going to get out a positive number. So thinking about vectors in this way, where we've drawn a triangle, you're always going to end up with a positive answer. But sometimes our vectors are pointing in the negative x direction or the negative y direction. And so I've included that explicitly on my own to tell us that this component should be negative because it's the negative x direction. Now I just plug in the values that are given, and if we plug those into our calculator, then you should get 2.6 for the y component and negative 1.5 for the x component. Now, if you didn't actually plug these into your calculator yet, I highly encourage you to do it right now and to make sure this is the answer that you are getting. If you get a different answer, that might be because your calculator is set to radians, and you always need to be careful to make sure if you're plugging in something in degrees, it's set to degrees. If it's plugged in, if you're plugging in radians, which we will do later in the semester, you want to make sure it's set to radians. And so people all the time in my classes in the past, even though I say it a million times, I always get some students who don't have their calculator set to the right thing. So make sure you do that right now. And if you find that it's set to the wrong setting and you aren't sure how to switch it, I'm happy to try to help you out in office hours. Of course, it'll be hard online, but I'll do what I can to try to help you figure out how to switch that mode over to be set to degrees when you want it to be set to degrees. All right, so that is how you can calculate the components of a vector given the magnitude and direction.